Hi everyone. Today we're going to go over encapsulation and what it means to encapsulate our data within a class. So this is a subset of information hiding, which we'll define in just a minute. So what is encapsulation? We're going to define some terms. We're going to start with information hiding, and then we're going to move into encapsulation. So information hiding is separating how to use a class from how it works. In C++, this is done explicitly with header and implementation files being separate files. We have a .h file, and then the implementation file would be the .cpp file. In Java, this is primarily done with access modifiers. Now in C++, you also had access modifiers, so these should not be new to you, but Java only does this with access files. So instead of in C++ where you have a header and a CPP file, instead we just have one file because everything in Java has one file, and we just use those access modifiers to adjust the level of access other things have to our data. This is also known as a form of abstraction. This is the most common form of abstraction that you will see in programming in general because information hiding is a very useful technique. Now, the next thing here is encapsulation. So the grouping of software into specialized units of code. This means that everything that belongs together stays together. Things that don't belong with it get moved out or abstracted to a different class. And we might use that class or interact with it, but we're not going to put it in my class here. That is this unit of code. Uh, we put implemented details behind a usable interface. So we hide the details about how something works from the people who are going to be using it. So when I, as a programmer, walk up to this new class, I'm not going to worry about how it's calculating the particular measurement that it's calculating. Instead, I'm just going to be like, oh, I need that measurement, and I'm going to call the function or method that allows me to do that. This is sometimes known as an API or an application programming interface. So when we're writing classes in Java, this is essentially what we're creating is an API for different pieces of data and different data structures that we create. We use encapsulation and other information hiding techniques for three main reasons. The first is security. So other classes shouldn't be able to mess with my data. What if they do it wrong or maliciously? What if they just put something in that's out of bounds, that they make my particular object no longer functional because of how they interacted with my data? The other is reusability. So I should be able to reuse my methods easily. This is part of normal use of functions and methods, but I should also be able to reuse my classes easily. And this means not worrying about the details of other classes. So I shouldn't have to worry about how something is happening because I should be able to just go and use it and do it and do what I need to do with that data that's returned or with that function call that got made. The last is maintainability. If a structure changes, it shouldn't affect my code too much. Now, when we're refactoring code, refactoring being when we change a lot of the details around maybe even method names, this is a common task, but it shouldn't change too much of my driver program or my other programs that are using that particular class. I should still be able to call either the same method name or a very similar method name with similar parameter calls. Now you'll note that sometimes when you're using other APIs or other classes from other libraries, that things get deprecated. Things are no longer used. That is a significant structure change at that point. However, this doesn't happen all the time. It certainly doesn't happen with every single update to a library. And we want to be able to have that kind of maintainability where I can use a method repeatedly over several iterations of a library, and that library is able to update and change its internal code. It's able to fix bugs or errors on its end without me having to worry about exactly what changes are happening or have too much concern over those details. Now, access modifiers. We talked about this a little bit before. You probably are familiar with them in C++, but let's talk a little bit about what access modifiers we have. So first, we have private. Only the owning object can access a private uh, either data field or method. So we can put access modifiers on either data fields or methods. And we have default, which is the same as private, so it has all the things of private, but in addition to that, it also has anything within the same package can access it. Now, what's unique about default is never an access modifier that you explicitly prescribe to a method or to a variable. Instead, this is what happens when you don't put an access modifier onto a method or onto a data object. So what you should do, you should always explicitly state what your access modifier is, because for two reasons. One, it makes sure that you can lock things down as much as possible because you're probably going to want most things to be private. And two, this also makes sure that it's explicit to other programmers so that other programmers know when they come to your code, when they look at it, what type of access this particular data field should have. Protected, so this is the same as default. Everything that is private, so only its own object, everything within the same package, and in addition to those two things, subclasses outside of the same package. So if I make a subclass, and we'll talk more about subclasses later on, so just hold on tight, don't worry too much about what a subclass is. Subclasses from outside of the same package. Now, a package is just a bundle of classes that we put together and we ship as a single unit, right? So everything that is within the same package and everything that the object can already access and subclasses from outside of its package can access that particular data member. Public is the same as protected, meaning that you get my own object can access it, my own package can access it, my subclasses, regardless of where they're located, can access it, and things outside of the package. This basically means everybody can see what it's doing, everybody can call it, everybody can access it, which could be problematic for things like variables, but we'll use this a lot for methods in particular. So accessing private data. Sometimes when we make data private, we still need to be able to access it in other ways. We need to access it in our main program. So that's when we implement getters and setters. A getter is also known as an accessor method. It allows you to control how data is returned. So if you have a date object, you can have different getters for each field, such as day, month, and year, or you could return a copy of the data object itself. And this is typically named as get data. So get and then the name of the variable or data that you are returning. With a setter, this is also known as a mutator method because we're mutating the data. And it allows you to control how your variables are modified. So it allows you to check for things like, is the data value within range? Do you need to copy the value or do you need to replace the reference to the value? So this is important when you're doing things like modifying an object because remember, objects, the name of an object, really is a pointer to the reference of the object itself. And the values within that object are not easily replaced by just swapping out those references. And are you setting specific portions of your data object? So instead of setting all of your data objects, such as with a complete reference change, you may need to set specific portions of it. So for example, if we have a person object and we have a first name and a last name, which are both strings, and let's say that one of these people that you have an object of decides to get married and they change their last name in this process. Well, that would be changing a specific portion of your data object rather than changing the entirety of it. So you could set it so that you only change a portion of that object. Now, this is typically named with a set data approach. So you'll have a set and then the name of the data that you're either changing or accessing with this method. The other thing that's important here is that you can overload your methods. When multiple method signatures exist for a single method name and return type in the same class, this is called overloading. The different method signature must have at least one of the following. They must have either a different number of parameters, different types of parameters, or a different order of the parameter types. This is really important. You can't have two methods with the same number and ordering of your parameters and also have it all be the same types. At least one of these things needs to be different. More than likely, you're going to have at least two of these, if not all three. When comparing method signatures, you want to remove all of the parameter names, but keep the parameter types and ignore the method definition. If the signatures look the same, then they are incompatible, meaning that you won't be able to define them. So again, when you have a method signature that is the public void uh, method name, right, and then the parameters listed in that method, take out the names of your parameters and ignore the definition of how you're actually implementing that method. If you look at that and you compare it to the other overloaded method signatures that you're using and they look the same, right? It has the same name, same parameter type, same order, then these are incompatible methods and you need to restructure your overloading. Also, you need to be wary of automatic type conversions such as int to float and excessive overloading. It's easy to go overboard thinking you need a bunch of different types of methods, different types of parameter inputs for particular methods when you probably don't in reality. So keep in mind, automatic type conversions do happen. So if you have an int and a float, for example, it's going to try to pick the best one, but sometimes it's going to convert and use the wrong one. So it might convert a float to an int or an int to a float. And you want to make sure that you're paying attention to that. All right, so next I'm going to show you a demo of a little bit what some of this stuff looks like, what overloading looks like, and we'll go over a couple other things in that demo as well. So we're going to cover some more slides and then we'll do the demo.